Hey guys, what's up and welcome back to another video. So here, as usual, I'm going to go through a complete walkthrough of the C1 paper, and this is set from May or June 2018. And actually, I've already gone through quite a lot of this paper, and I'll tell you right now that this paper overall is pretty good. Not as bad as the previous is, so thankfully that's good news. And don't forget, this is going to be probably the second last paper before the final sitting in 2019. If, well, when you see this in the future, we're not there yet already. But anyway, let's go through each question, and as usual, I've covered a lot of these questions. I'm just going to go show you how I did each one. So let's begin. Number 1. So simplify the square root of 48 minus 6 over root 3. Write your answer in the form a root 3, where a is an integer to be found. So I've already obtained the answer here. But the key idea is to always try and break down each of these two components. So first, we're going to try and break down root 48 and then 6 over root 3 and simplify these both to get a nice simple surd. So looking at root 48, my tip is to always use factor trees. And that is to always break them down into products. So 48 can be seen as 2 times 24, so put some nice surds on both of them. And then 24 can be broken down as 2 and 12. 12 can be broken down as 2 times 6, and 6 can be broken down as 2 times 3. The most important thing is that when you break these down to the lowest numbers, these are always going to be prime, because once you get to prime numbers, you can't go down. And now to actually obtain the result, all you have to do is simply circle all the values you got, okay, all your final segments, and then see if you can make whole numbers. To make whole numbers, if you get two similar surds like root 2, these can combine to make a whole 2. These two root 2's again combine to make a whole 2, so now we got 2 times 2, which is 4. And finally got root 3. So the answer here will be 2 times root 3, which is 4 root 3. Remember, 2 2's make 4 and then stick a root 3. Easy stuff. Now for the next bit, 6 over root 3, we have to rationalize it. In other words, you can see that there's no root 3 at the bottom, so we need to times up and down by root 3. That's all. We always do this. Every single procedure always times up and down by whatever's at the bottom. If it's something like root 3 plus 1, then you have to times up and down by root 3 minus 1. Because the key idea here is that what it does is that it will automatically clear the bottom, so there's no more surds. Anyway, for this one, timesing up and down, 6 times root 3 will of course give us 6 root 3. And then root 3 times the root 3, just like the previous one, will give us a whole 3. Because 2 of the similar surds give us whole. And then cancelling this down, 6 over 3 is 2, so it's 2 root 3. And that's it. So the final answer is the first term minus second term. So 4 root 3 minus 2 root 3 will give us 2 root 3 itself. Done. Now, let's look at part 2. Solve the next question. So we got 3 to the power 6x minus 3 equals the whole number 81. Okay, so we've got powers in indices and wholes. So write your answer as a rational number. Okay, so here's our final result. Now the trick is to firstly look at these numbers and think, what do I do? Because you're not using logs from C2, the key idea is to firstly recognize that 81 is a solution of a power of 3. We need to firstly realize that 81 is the same as 3 to the power 4. And you can only solve these kind of questions if you have the same base. So we need to work in bases of 3. So essentially we have 3 to the power 6x minus 3 equals 3 to the power 4. And because we've got the same bases, we can assume that this 4 must be equal to 6x minus 3. And that's exactly what we get here. Okay, so I just put and this is just little observation skills. So once you do this is easy maths. Just plus 3 across, so you get 7. Divide 6, you get 7 over 6. And that's it. All done. Well guys, if you like this video so far, give me a like. I'm just doing this carefully, step by step, so there's nobody missing out. But anyways, if you're enjoying this, give me a like, subscribe, share with your friends. Otherwise, let's move on. Okay, number 2. Now this one is very easy. So given that you get this equation here, which is a mixture of surds and linear terms, find the integral of this equation, simplifying each term. So integrating this equation. Now, before you solve this, remember to always convert everything into the standard indice form. So in other words, you don't want to get surds or fractions. You want them all in something to the x to the power something. So it looks nice and clean. So root x is the same, firstly, is the same as x to the power half. This is, remember, the square rooting is literally the inverse of squaring, hence the 1 over 2. So this means we've got 3x to the power half and so on. Now to integrate, differentiate, and so on, this is easy. to integrate this term, all you have to do is really raise the power up by 1. So half plus 1. So we're going to have, for example, 3x. Adding 1 to half will give us 3 over 2. And then divided by 3 over 2. And then move on to the next term. 6x, you raise the power by 1. So this is power 1. This becomes power 2 all over 2. And if there's no x terms, you just stick in an x. And oh yeah, don't forget the plus c. So trust me, a lot of people have actually missed out 100 UMS because of this little plus c. And end up with 99, which is still amazing though. And yeah, now just simplifying this, we're going to do 3 divided by 3 over 2. Now the trick for these ones is that what I do, instead of just mentally thinking about this, you can just realize that if it's a fraction underneath, we just cross out this 2 and just times it here. Because that's the same as the principle 3 divided by 3 over 2, which is the same as 3 times 2 over 3, by flipping the fraction upside down. And yeah, that's it. And now just simplifying this, 3 over 3 cancels out and you got 2 left. So all of this becomes 2x 3 over 2 minus 6 over 2 cancels out to 3, x to the power 2 plus 4x plus c. Easy stuff, yeah? Now let's move on to part B. Okay, so part B wants us to differentiate. So differentiating this equation here, the red term one, the standard y equation. And it's easy, just like integrating. Instead of raising the power, you subtract the power, but you drop it first, then you subtract. So first you're dropping half down. 3 times half is 3 over 2. X, subtract the power by 1 is minus a half. Next one, drop the power by 1, so it'll be 6 times 1 is just 6. And then because it's just an x, it disappears. And then 4 just cancels out because differentiating a constant is 0 because there's no x term to work with. That's it. Now finally, hence find the value x such that dy of dx is 0. So we just say, alright, when dy dx is 0, basically equate this whole equation to 0. And oh yeah, let's convert this to its nice form. So 3 over 2x to the power negative half minus 6 equals 0. X to the negative half. So remember, when you got a negative sign, it means reciprocal. So it means 1 over x to the half. And we know x to the half is the square root of x. So 1 over root x. Okay, so plug that back in. So you got 3 over 2 times 1 over root x. That's just basically 3 over 2 times root x. Minus 6 equals 0. Now we just solve for x. So 4 marks, that's quite big. So what I would do is plus 6 across. So 3 over 2 root x at the bottom equals 6 times 2 root x across. So clear the fraction. 2 root x times 6 is 12 root x. Divide 12 across. So 3 over 12 is a quarter equals root x. And now, this is the part where you got to be very careful. Now we need to square both sides. So try not to accidentally square root this. If you square both sides, you get 1 over 16 equals x. Okay guys, welcome to number 3 now. So let's do this. So we're given a function which is a typical quadratic formula, quadratic expression. And we need to express this quadratic expression into this typical form. Okay, so we've got x plus a all squared plus b. Now, if you haven't seen this before, this is known as completing the square. And it's super easy. You literally have to think of a perfect square and 2 numbers that multiply, which will give us at least the first 2 terms, x squared minus 10x. That's the general idea. The plus 23 is pretty much the error. So we want to find the error difference. So what I did here is that I looked at the original equation, and by the way, this works all the time. I just half the coefficient of 10 and get 5. Wrap up in a nice bracket, x minus 5 all squared. So that's why I drew a nice red line over here. And then copied out the next bit, plus 23. And realized that I had to minus this term squared, 5 squared, because this will give us the exact error. And when you do this, so it's always like this, you get the same expression, 23 minus 5 squared minus 25 is minus 2. So that's it. So in fact, this is pretty much a perfect square with 2 less, and that'll give us the original expression. That's it. That's really all you have to do. So that's our perfect square, and that means a is going to be minus 5 and b is going to be minus 2. That's what we do. Now, let's look at part B. So hence or otherwise, find the exact solution to what we just did. So we're going to use firstly the completing the square format. And notice that all that's happened is that the function fx is now equal to 0. So yeah, so let's whip it out. Let's let fx equal 0. So set this equation to 0 and solve. So plus 2 across, like I did. Get rid of the square by square rooting, so you get plus minus root 2. And finally plus 5 across. Done. So you should get 5 plus minus root 2. And they don't tell you, they said find the exact solution, so they want the plus minus result. That's it. Not much to say there. Now part C. So using your answer to part B, so this result here for x, find the largest solution to this equation. Oof. So when you look at this head on, it looks a bit intense, but really it's just the first equation powered down by halved. So instead of x squared, you get y. Instead of x, you get y to the power half, or 0.5. So essentially you could say, okay, y is clearly x squared. So what I did, I just let y equal x squared. Or you can say x equals y to the power half, or that. And all they want you to do is repeat this, but this time find the solution to the larger part. So find the plus result, not the negative solution. Because you're given a plus minus answer, the larger solution is always the positive one, the one you add. So pretty much do the same thing. So instead of solving for x, so we got y equals x squared. So we can say, okay, let y equal this solution squared, because it's the same thing. And then you just expand this bracket. Notice that this bracket here is a quadratic, because this is a square function here. This is essentially 5 plus root 2 times 5 plus root 2. And when you expand it, you just do like you do for quadratics. So you got 5 times 5 is 25, 5 times root 2 is 5 root 2, root 2 times 5 is 5 root 2, and then root 2 times root 2 gives us a whole 2. And then collect everything, and you should get 25 and 2 is 27, 5 root 2s, add them up, you get 10 root 2s. And that's it. Question and problem solved. So question 3 isn't really difficult. Once you get through this completing the square bit, it's all, rather straightforward, I guess. But anyway, guys, if you enjoyed this video, give me a like. But otherwise, let's move on. So each year, Andy pays into a savings scheme. In year 1, he pays in £600, and his payments increase by £120 each year. So he pays £720 in the second year, £840 in the third year, and so on. So these payments form an arithmetic sequence. So they already taught you what to do. So before we even solve this question, let's label A and D. We can say firstly A is the first term, which is 600, and the common difference D is plus 120 because it's going up in 120s. So this is your first term and your common difference. So part A, find out how much Andy pays into the savings scheme in year 10. So in the savings scheme year 10, you just have to literally find out how much he gets in the 10th year. So in other words, U10 or Y10. And now I solved it down here already. First things first, we need to know the general formula, which is quite easy, I think. It's always A plus N minus 1D for each year. And because we want the 10th year, this means N is 10. And because we already know the value of A and D, which is 600 and 120, just plug everything back in. And then you solve, expand, and voila, you get £1,680. So that's how much Andy got in that year. So pretty easy so far, I guess. Now here comes the main bit. So let's do this. So Kim starts paying money into a different savings scheme at the same time as Andy. Okay, so this is a totally different arithmetic sequence. In the first year, she pays 130. Her payments increase each year so that she pays 210 in the second year, 290 in year 3, and so on. So they don't tell you the common difference here, but we have to realize that it's going up by £80 every year. So we can say that D here is 180 for Kim, and if her first payment was 130. Okay, so that's the slight key differences here. Now at the end of year N, okay, so we don't know what year exactly, Andy has paid in total twice as much money into his saving than Kim has paid. So Andy has paid whatever Kim has times 2. And yep, we go find value N. So I will start from this statement here, this second paragraph. So part B, what I said, at year N, we know that Andy paid 2 times the amount Kim paid. So this SN is the sum formula that I put here. So the total amount Andy paid equals 2 times the total amount Kim paid. Okay, and that's it. So this is pretty much our equation we work with. So all you do here, guys, is literally just find the sum for the SN formula for Andy and SN formula for Kim, plug into this formula and solve for N. So let's do it. So we got all the variables. We got for Andy, we got A is 600 and D is 120. So the general sum expression, and by the way, this is I believe it's given in the formula sheet anyway, but I recommend you memorize this. So plug in the value for A and D, so you get 600 here and 120 there. Plug in replace N with capital N, and I put D in front because it just looks neater that way. Then you just expand. So a quick way to expand this, guys, is to really just cancel out. Because you got N over 2 times 600, cancel the 2's and you got N times 600, 600N. And you got N over 2 times this expression. 120 over 2 is 60, they cancel out. So n times 60 times all of this will give us 60n squared and 60n. And then collect like terms, which will give us 540n. And of course, plus 60n squared. So do the same for Kim as well, because this time Kim has a first term of 130 and a difference of 180 pounds. And you just repeat the method. God, 80 pounds, yep. Difference of 80 pounds. Plug it in and you should be good to go. And doing that, you should get 40n squared plus 90n. Now, this is the main part. So once you guys come to this conclusion, put this back into the original equation here. So the sum of Andy, it would equal 2 times the sum of Kim. So it would be 60n squared plus 540n equal to 2 times this, so 80n squared plus 180n. And I put it here. Okay, so you guys should be here right now. And when you get here, literally just solve for n. And the best way to do this is probably throw everything on one side and make it equal to 0. So I just threw everything to the right side. So I subtracted 60n squared to get 20n squared, threw 540 across, and I got minus 360n overall. And all of that's equal to 0. Now this is easy. Divide 20 across to get n squared minus 18n. Factorize the n out, and you're left with 2 solutions. N equals 0, which is basically the payment in year 0, which we don't care about. Or n equals 18, meaning after 18 years, that's when Andy gets pays twice as much as Kim. Now, this is the end of the solution. We found n is 18, but sometimes, you know, in the exam, there's a lot of pressure, especially these long questions. I would firstly plug n equals 18 back into both of their formulas, into both the sum equation, just to see how much they really get in pounds. When I did that, I realized that when I plugged n equals 18, turns out Kim actually paid 14,580 pounds, while Andy paid practically double, 29,160. And to check this is exactly double, you can see that 2 times 14 times 14,580 is the same amount Andy paid. And voila, that's it. You don't have to do this bit. This is just a verification check for ourselves, just so we can see the figures ahead of us. But yeah, as long as you guys got this first statement done, then you did well. Anyway, guys, yeah, so thanks for watching so far. And I'm going to move on to question 5 now. So figure 1 shows the sketch of a curve with equation y equals fx, so just a nice general name. The curve crosses the y-axis at 0, 4, and 5, 0, so typical ones, just always crossing over here. Now, the curve has a single turning point at 2, 7, which is over here, the highest point here, which is also the turning point. And now the line of equation y equals 1, i.e. the dotted line here, is known as the asymptote. And what asymptote means, for you guys who don't know, is when the curve itself will stretch on for infinity forever, but never ever reach y equals 1. So the closest you'll get is probably y equals 1.00000, like infinite 0 is 1. And even then, it will still never touch. So that's what it's for. Okay, so let's begin now. So A, state the coordinates of the turning point on the curve with equation y equals fx minus 2. Now what this means here is that firstly we're dealing with a curve called fx, and now we want to find fx minus 2, the turning point. All this tells us that for the x values here, if it's x minus 2, this means we need to add the x values by plus 2. That's all it is. When you're working with x coordinates, it's always reverse. Okay, so we look at x coordinates here. This is the turning point. It was originally 2, 7, so we add 2 to the x value, it becomes 4, 7, so it moves to the right by 2. So the coordinate here is 4, 7. B, state the solution of the equation of f 2x equals 0. Now, notice how this was y equals fx. This means that the y, we're trying to find when the y coordinate is 0. So in other words, when it's on this line here, the x-axis. Because y equals 0 means it hasn't literally jumped off the x-axis. So somewhere on this line. And 2x literally means, just like the previous one, is that you don't double the x coordinates, in this case you halve it. So all the x values are halved. So the only time that it hits the x-axis is 5, 0. So half of 5, 0 is 2.50. So that's our answer. So we want 2.50, or you can also write 5/2, both is fine. So that's easy. Now C, state the equation of the asymptote to the curve with the equation y equals f minus x. So in this case, all the x values are flipped, are negative, but we just flip the signs. So here previously we had 2, 7. This means that 2, 7 will appear now here as minus 2, 7. 50 down here will appear on the left side as minus 50, so let's put it around here somewhere. 04 is the same because flipping 0 is still 0. So all that really happens is just a nice transformation. So it's going to be kind of hard to sketch, but well done. You literally have to just copy this diagram, sketch it over here, and then this again will never touch the asymptote. So actually everything is the same. So in fact, you can see that the asymptote position doesn't change because the curve is identical. It just rotates, it just flipped against the y-axis. So we say that asymptote is still y equals 1. Easy stuff. Now, final question. So given that the line of equation y equals k, so y equals k could be something like, I don't know, y equals 2 or y equals 3. Just a constant. In other words, it's a straight line cutting the y-axis. A bit like the asymptote, which is y equals 1. Now, so given that the line of the equation y equals k, where k is a constant, meets the curve y equals fx at only one point, so key point at only one point, so it crosses the curve at 1 point, so it can't be, for example, here because it's 2 points, 2 points. So really it just means up here or below the asymptote. State the set of possible values for k. So I've already written the answers, but what this really means, the only exact point would be when it hits at the tip at exactly 7, but that's again only exactly at 7, or when it hits below the asymptote, or at the asymptote and below. So when it hits at the asymptote and below, it's going to hit at y equals 1, or less than at 0, minus 1, and so on. So the only possible values is when it hits at 7 or below 1. So that's our answer. So it would be 7 or below and equal 1. And that's it. That's literally, what number is this? Question 5 done. Sequences. This is actually my favorite question of the whole paper, and I mean it. This is really nice. If you guys have sequences in your exam, call it a blessing because it's really good. But anyway, let's have a look at the question. So we got a sequence which is A1, A2, A3 is defined by the given ones, where A1 is 4 and every next sequence after is defined as the previous term over the previous term plus 1. So when I say that an plus 1 and an, this is simply the next term up after an. So to find a2, you plug in a1 results. To find a3, you plug in a2 results. To find a20, you plug in a19 results. So it's always the next sequence up. Now let's look at this. A. Find the values of a2, 3, and 4. Okay. Now this was really straightforward, and I don't know why I left the answers there. All you do really, to find a2, you plug in a1 results. So it's going to be 4 over 4 plus 1, so 4 over 5, and that's, well, 4/5. To find a3, you plug in a2 results. So you can use the answer a2 into the formula, so it'll be 4/5 over 4/5 plus 1. And when you tidy this up, there's a really nice way. When you've got fractions in a fraction, you want to try and clear the fractions inside there. So because they're both over 5, I times up and down by 5. Because it's like times by 1, it has no effect. When you do that, 4/5 times 5, they cancel out the 5, so you're left with 4. When you times the bottom by 5s, 4/5 and 5s cancel out, you're left with 4. And then 1 times 5 is 5. And then you're left with 4 over 9 when you tie this up. Easy. As for a4, you just use your a3 results and then copy what we did. Because now you got 4 9s over 4 9s plus 1. You want to times up and down by 9 to clear out the 9s. And doing so, top half becomes 4. And bottom half, this first term becomes a 4. And times into this by 9, you get a 9. And then tidying this up, you get 4 over 13. That's it. Not bad. This is why, you know, sometimes they're tricky, but you just have to really be careful when you simplify. Like I said, when you got fractions on fractions, always try and clear the fractions first before you do anything else. Okay? Alright, let's look at the next bit. So given that you got an equals 4 over pn plus q, so this looks like a general, they're trying to make a general nth term now. State the value of p and q. Okay. So this is just pure observation skills. You'll realize that there's a 4 on the top. And when you look at our working outs, we always had a 4 after we did some kind of techniques, times in by 5s or 9s. So one thing you can kind of observe from here, like just looking at head on, if they both got 4, this means that the bottom half must be equivalent to this expression at some n value. So what I'm trying to say here, like let's look at a2. You can say that when n is 2, we can have basically p times 2, so 2p plus q is going to equal the bottom half, which is 4 plus 1, which is 5. So 2p plus q equals 5. So what I thought, you know what, let's match each term. So at a2, we can say that the bottom half of a fraction here, when n is 2, we get 2p plus q, and this is equivalent to the bottom half of our solution, 5. For a3, when n is 3, we're going to have 3p plus q, and this is going to be equal to the bottom half of our a3 solution, which is 9. And that's it. You could do the same for a4, but it's just nice to have like a general pattern. Now, what they want you to do here, which is quite clever, is that you're going to use simultaneous equations now. So this is not obvious, but that's what they want you to do. You're going to simultaneously solve some of these. So what I did, and I used the first two, I subtracted a3 from a2. So look at these two equations here. So subtracting these two, you're going to get the q's cancel out, and you got 9 take away 5 is 4, 3p take away 2p is 1p or p, so that immediately gives us a result. And now because you got p equals 4, you can plug it into any equation. I plugged it back into the first equation because you got 2 times 4 is 8, and then 8 plus q is 5, so q, solving it will give us minus 3, and that's it. Now part C is actually similar. It says, hence calculate the value of capital N such that a capital N equals 4 over 321. Again, you still got a 4 at the top, so you can say basically that wherever this solution is, Pn plus Q has to equal 321. That's the first step. But because we got P and Q already, we can put them back in. So we're going to have n times 4, so 4n minus 3 equals 321, if that was it. And then we could just solve it. So plusing 3 across, you get 324, and then dividing by 4, you get 81. Voila. Alright, number 7. Oof. This one was a very straightforward question as well, but let's have a look, because sometimes it can be tricky. So they give us an equation which is 20x squared equals 4kx minus 13kx squared plus 2, where k is a constant and has no real roots. Okay, this bit here has no real roots. That basically implies this statement here, b squared minus 4ac less than 0. When something has no real roots, we're talking about a quadratic equation, the inside the square root bit. When you use a quadratic formula, remember how we always get plus minus b plus minus the square root function over 2a? We're talking about this bit here. When this term is less than 0, you get a negative solution, and a negative of a square root is literally results in a math error. So that obviously can't do. So that's what it means. This means we'll get no solution. This will mess up the solution. So when this is less than 0, this means no real roots. So that's all you have to take from here, this bit here. If it said it had 2 real roots, then the sign would be greater, because then you have a plus minus solution. If it says it has 1 root, it means that these two are equal to each other. So this bit cancels out, and you're left with 1 solution, minus b over 2a. So that's all it really means. So 1 solution is an equal 0, 2 solutions is greater than 0, and no solutions is less than 0. Okay, that's all it is. Now, let's solve the problem. So show that k satisfies this inequality. Okay, so to use b squared minus 4ac, we need to realize that we need to firstly rewrite this into a quadratic expression. So what I did, I threw all of this to the left hand side and then collected like terms. So we have, for example, 20x squared plus 13kx squared. So I factorized x squared and realized that we have 13k plus 20. So this would be our a term. 13k plus 20 is a. Minusing b across, 4k plus 4kx, you get minus 4kx. And then throw 2 across and you get minus 2. So you got b and c done. Now, replacing this into the b squared minus 4ac to prove this equation, replacing b with minus 4k squared, replacing a with 13k plus 20, and c with minus 2, you literally just solve this now. Or simplify it. So one quick way to do it is that, especially this a and c bit, when you got minus 4 times these two terms, I always do minus 4 times the easier term, like minus 2, because this will give us a plus 8. And then you can finally expand this bracket. And really, the reason why is because if you times this one first, and then this one, you could risk getting a wrong answer. It's very likely. It's better you do the easier ones first. Okay, just little math tips. But yeah, expanding all of this one is easy. And from this step to here, I just divided by 8 because I realized that 16 and 8 are both 8 times table. Dividing by 8, you get 1 and 2. And then expanding this one, you get the same result. And because the solution tells us it's 13k plus 20, so we know that this bit was fine. So we could just divide by 8. And that's it. Done. Now, for part B, it It says find the set of possible values for k. So this means just literally factorize this expression here. I've already done it, but to pretty much know how to get this by factorizing, let's pretend you didn't know it was 5 and 4 for a second, yeah? Just so we can understand it. The key idea is to always realize that we need two numbers that multiply to make 20. So the two pairs could be, for example, 1 and 20, 2 and 10, or 4 and 5. Now, when you got 2k and k, because remember it's 2k squared, so it's going to be 2k times k. When you have a constant like an a term which isn't 1, so you got 2, we basically need to multiply one of these figures by 2 and add them up to get a sum of 13. So what I'm trying to say is that, for example, if I did 1 times 2 plus 20, I'll get 22. So this is clearly wrong, so we can't use this. If I, for example, times 2 by 2, so 2 times 2 is 4 plus 10, we get 14. So it's close but wrong. Or if I times 2 by 10, I get 20, so 22 is still wrong. But if I use the last solution, if I times 4 by 2, I get 8. 8 plus 5 is 13. And yes, that gives us a result. So we need to do 2 times 4 and 5. So 2 times plus 4 is 8. Plus 5 is 13. And voila, that's how I personally do it. You guys might have another way, but for me, this way is easy because you just list all your options and then just see which one the multiplied will give us the right sum. Easy, really. Okay, that's done. Oh yeah, critical point. So now just make this equal to 0 and you realize 2k equals minus 5. Divide by 2 is minus 5 over 2, and same for this one. K is minus 4. Now when you do this one and we need to find all solutions, set possible values for k, you could use the graph method or you could use this number line method. With the number line method, I just put between the number lines, so between minus 4 and minus 5 over 2, and I just place k values between it and see which is true and false. True statements mean this is where the answer lies, and false statement means is completely wrong. So we don't care about it. So what I did for the left side, I just chose a number for k, which is less than minus 4. I chose minus 5. So when I plugged in minus 5 into this first equation here, I realized that I got 2 times minus 5 plus 5, which is minus 5, and then minus 5 plus 4 is is minus 1, and then times in this I got plus 5. And you can see that 5 is not less than 0, so this statement is wrong. What this means is that any value less than 4 is false, so k is definitely not less than 4. And I did it for the right side. I put a value bigger than minus 5 over 2, so I chose 0. So plug in 0 into the equation, you get 0 plus 5 and 0 plus 4, which is 20. And that's obviously not less than 0, so that's also false. So this statement is wrong. And then when you put a value between minus 4 and minus 5 over 2, I chose minus 3. And then plug in minus 3 here, and I got minus 1. And yes, minus 1 is less than 0. So this means this section is true. So this means k must be okay between minus 4 and 5 over 2. And that's it. Okay guys, here we go, number 8. Oof, geometry. Okay, so this question was actually pretty easy, you know. Overall, I wouldn't say super easy, but I'll say it was definitely very doable. Now, one thing I want you guys to know is that when you see lines like this, which looks like it's practically parallel, don't assume it's parallel until you read the information below. Okay, it tells you here later on that this line is parallel to the first line. Okay, the key idea is that when you have parallel lines, that this indicates that the gradient for both of them is the same, so they have the same m values. It's quite, maybe it sounds quite obvious, but this is very important to solve these kind of questions. And typically, when you have the same, when you work out an equation of a line and you see these points A and B, you would automatically have them because they are known as the y-intercepts. But anyway, since we got that out of the way, let's have a look at all 4 parts then. So let's have a look. So figure 2 shows the straight line L1, so the first line, with this equation 4y equals 5x plus 12. State the gradient of L1. Now the reason why this is easy is because they've pretty much spoon-fed it for you. Now the equation of straight line is always y equals mx plus c, where m is the gradient. Now because this is a 4y, you would have to firstly get rid of the 4 because it needs to be y equals. So if you divide this all by 4, you should get something like 5 over 4x plus 12 over 4, which is 3. And that's it. And then you can clearly see that the m value here is 5 over 4. And that's it. So the first line here, if I just label it at the top, is going to be y equals 5 over 4 x plus 3, where 5 over 4 is the gradient. So you just say m equals 5 over 4. Okay, so that's good. That's good. And this plus 3 is important because this tells you that the y-intercept is 3. So this a coordinate actually hits at 3. So we know the coordinates A is going to be 0, 3. That's it. That's actually helps a lot. Now next part. The line L2 is parallel to L1, so yep, they are indeed parallel, and passes through the point E12, 5. Okay, so since we know this is parallel, we're going to have the same equation, except instead of plus 3, we're going to call it plus C and find out what the y-intercept is. Now find the equation of L2 and write answers in the standard y equals mx plus c form. Okay, easy. So let's go ahead and jump straight to the point that we know that the equation line is so far is y equals 5 over 4x plus c, and we can use this point 12, 5 because it's on the line to determine the value of c. So what I did over here, I put everything down. So at point C, you can literally, at point E, you can just literally plug this in, x is 12, y is 5, into this L2 equation, and literally just solve for c. So when you plug in y is 5 and x is 12, you can simplify 5 over 4 times 12 into 15, because well, 4 goes into 12 3 times, so you got 5 times 3, or you can do 60 over 4, which is 15. Either way, quick mental maths, solve this and your c is negative 10. And that's it, that's your line for L2. Same equation, but minus 10. So if we put this over here, and just, because it actually helps when you always update your graph, and you can compare. You can see that this line is exactly 13 units up, because that's the difference between 3 minus 10. And the y-intercept is minus 10. So it hits the y-axis at point B at minus 10. Trust me, this is going to help a lot. Okay, so next one. The line L2 cuts the x-axis at point C and the y-axis at point B. So that's these 2 points here. We already solved one of them. Find the coordinates of B. Well, B we just did. It hits at minus 10. So it's going to be 0 minus 10. Because it doesn't move across, but it just goes straight down by 10. As for C, when it hits the x-axis, this means that the y coordinate is 0 because it literally hasn't moved up or down. So it's still on the line. So y is 0. So when y is 0, you just plug it here and you solve for x. So I did that here as well. So at point C, when y is 0, plug in 0, just solve for x. So plus 10 across, times 4, and then divide by 5, you should get x equals 8. So the x coordinate is 8 when y is 0, so the coordinate is 8, 0. And that's it. So you put 8 and 0. So like I said, this question was overall pretty easy, and you don't usually get questions like this. Usually they're a lot tougher, but you know, this is actually good. This is actually a good sign. Now next bit. The line L1 cuts the y-axis at point A, so we did that, and we got a coordinate, which is 0, 3. The point D lies on L1 such that ABCD is a parallelogram, as shown in figure 2. So we know that all of this is a parallelogram, so just draw some lines to indicate it. So that's good. So if this is a parallelogram, and you know this is 3 and minus 10, and this is exactly 13 units above, and we got the value C, which was 0, which is 8, 0. We can see that this is 13 units up, so this D coordinate would be 8, 13. Okay, yeah, why not? Find the area ABCD. So to find the area of a parallelogram, it's literally just the vertical height times the horizontal base. And I'll show you what I did because it's such an easy way to figure this out. Once you sketch it here, I mean, I might as well just, put this here, I guess. My tip is to really look at this bottom half of the triangle. You'll realize that for a parallelogram, you could literally just take out this shape here and place it on top here to get literally a perfect rectangle. And that's it. And that's why we use the base times height, because a parallelogram can be transformed into a rectangle if you just crop out this bit. So that's it. And now, what is the height? So because you just pulled out the first 10 units and plugged it above, you basically got a total height of 13. And you know that the width is 8 because from 0 to 8 is, 8. So the final answer is just 13 times 8, and that should give you 104 units squared. And that's it, guys. That's literally this question done. So 9. So the curve C has equation y equals fx, all right? Where the first derivative, so f prime x equals x minus 3 and 3x plus 5. Now, I just decided to expand this because, it's just always nice to have a complete looking equation. So expanding this quadratic and tidying up, you should get this result for f prime x. Now, given that the point P lies on C, so remember, this is the x and y coordinates. So the only way to really do this is that you need to use the y equals fx. So you need to integrate this. Find fx and simplify in each term. So this is straightforward. To go from f prime x, you need to integrate to have fx. And when I integrate all of this equation here, I got something like, where is it? Over here. So integrating 3x squared minus 4x minus 15, just raise the power by 1 for each one. So this becomes 3x cubed over 3, 4x squared over 2, and this one just has an extra x because there's no term. And don't forget plus c. And I say all that equals fx. And of course, try and simplify. So 3 over 3 cancel out, so these two disappear. 4 cancels out with 2, so it becomes 2x squared. And because we know in the beginning that y equals fx, just replace fx with y. And that's it. And now we say, okay, now we have to try and find the value c. Because when you find the value c, then you've pretty much found the complete fx. And that's why they give you corners. The whole point of this corner is to plug in to find the actual full equation, not plus c. So anyway, at point P, we just plug in x equals 1 into the equation and y equals 20. And when you do that, just solve for c. Just rearrange this and find c. And you get, hopefully, 36. And then because it's 36, just write down the full complete equation with 36. That's it. And to me, that's an easy 5 marks. Can't lie, very straightforward. Now, part B. Show that fx equals x minus 3 all squared times x plus a. Okay, so that's literally 2 lots of them, x minus 3 twice, where a is a constant to be found. Now, to find a is actually dead easy, because one thing you have to realize is that this fx is basically the full expanded one we have right here, where we just deduced. And to get the value a, what you have to realize that if you multiply all 3 constants, minus 3 times a, it should give us a result of 36, because if you expand it, that's what happens. So to find a, you just have minus 3 times a is 36. So you get 9. So you got these two gives you 9. So 9a equals 36. Let me write down. Then you just divide by 9 and you should get a equals 4. That's the easy bit. However, sometimes I thought this was a bit too easy. So I realized, and I'm not sure this is 100% guys, you might have to check with me when the actual mark schemes are out, is to actually deduce this expression, how to actually factorize it. So what I did here, I did a little expanding. I said, okay, let fx equal general x plus a, x plus b, times x plus c, just a general way. And then you just have to expand every term. Now, like I said, this could be pointless, but I mean, there's no other way to actually show this. Well, there is. And when you do this, I times the last 2 brackets to get this expression. So x times x is x squared, x times c and x times b gives you this when you collect it, and so on. And you expand the whole lot, basically, all 3 brackets. And you get something like this kind of nasty looking this cubic equation. So basically all we say now is that for the x squared term, we know that if we compare it to the fx function, we can say that a plus b plus c is of course identical to minus 2 because it's the same value. We can say for the x term, all of this is identical to minus 15. And of course the constant term is identical to 36. And then you make an equation. Now, like I said, this is just a method, so I would like to hear your comments on this one. Anyway, that's it really, and you've done that. And C is dead easy. Now part C, how to sketch this curve. Now this cubic curve is very straightforward. Okay, all you have to do is realize that each of these factors are points where you hit the x-axis. For example, x minus 3 means you hit the x-axis at plus 3. So let's assume plus 3 is here. Whereas x plus 4 means you hit the x-axis at negative 4. So let's go back and say minus 4 is here. Now, typically a cubic curve always looks like a snake going from the bottom to the top. So the shape is generally starting from the bottom, you curve down, curve once more and go up. This is a typical positive x cube graph. And you know it's x cubed if you've got 3 factors, or if you multiply the first 3 x's to get x cubed. If you had a negative, if somehow when you expanded this and you had a negative x cube, something like this, the shape would be going downwards, a bit like this, curving up and then finishing down. So remember, positive x cube, you start from the bottom and you go up. Negative x cube, you go down and you finish down. Now, because we have 2 repeated roots, this means that it's going to hit x at 3 twice. So in other words, it's going to bounce off 3. So let's go ahead and sketch this. We're going to get to the y-axis in a second. All you're going to do is start from here, shoot up, oh man, I missed it already, go down, and then bounce on this, and then go up. And that's it. You don't necessarily need to draw the arrow, but I'm just doing it for demonstration purposes, yeah? So again, this has to hit at minus 4, and hit here at plus 3. Now, as for the y-axis, I mean, the curve could be, the bending point could be anywhere, so let's not assume that the turning point hits here. To get the y-axis, this is simply when x equals 0. So if you plug in x equals 0 here, you're going to end up having, 0 minus 3 times 0 minus 3 times 0 plus 4. And essentially, what this means is that you can have minus 3 times 4, which will give us 36. And that's it. This is literally all you have to do, guys. So looking at its head on, you can see that we've got a curve here which intersects at 2 different points. So I'll tell you right now that there's going to be simultaneous equations, because the only way to get a and b is to use simultaneous equations on the line and the curve. Okay, so that's going to come up. Now let's check out what's happening. So the figure 3 shows a sketch of part of a curve C with the given equation. Okay, so this one looks a bit nasty, but not too bad. The point A lies on C, so over here, and has a coordinate of 3 and minus 3 over 2. Okay, so keep that in mind. Now A, show that the equation of the normal to C, so the normal as in the perpendicular line at this point, can be written in this equation. So this equation is actually a perpendicular equation. So one thing to note, to get the normal, you first need a tangent, and the tangent at this point is basically an imaginary straight line that touches exactly once. So this line here is 90 degrees. This normal is 90 degrees to the tangent. Now to get the actual value of the gradient of this line, because remember, the typical line, this is just a straight line equation. So the typical equation is always y equals mx plus c. We just need to find the value m, and m is going to be the perpendicular gradient at the point A. And to get that, you need to differentiate this value, because dy dx is also known as the change in y over the change in x, which is the gradient. And when you find that, just take the reciprocal negative sign and you're done. You found m. And to find c, just plug in the a value and you got it. So I'll show you what I did. So this is just the same statement. So the first thing you want to do is differentiate the curve, okay, and then plug in the value a. So to differentiate this one, firstly rewrite this equation in a nice way. So I always write this as x over 2 plus, now this one I'll write in power form, so it'll be 27 x to the negative 1, because you've got to bring it up, minus 12. Now when you differentiate this one, the x vanishes, so it's 1 over 2, and then this one, you drop the power down, so it'll be minus 27x, and this goes down to negative 2, so it looks like this. And then you can rewrite this one in a nice formal way, which is 27 over x squared, and that's your dy dx, by the way, so keep that in mind. So now all you want to do is firstly plug the value 3 inside to find the actual value dy dx. And when you do that, you get half minus 27 over 3 squared, which is 9. So that becomes 27 over 9, and that becomes 3. So half take away 3 is minus 5 over 2. So that's the value dy dx. So that would be the gradient of this line here. So the gradient of this line here would be minus 5 over 2. But because this is a perpendicular line, this line would have a gradient of 2/5. So you change to a positive and you flip upside down. Okay, so that is easy. So we know the gradient now is 2/5 x. So that's what we have so far. So now we have y equals mx plus c. We now have y equals 2/5 x plus c. And because we know point A is on the line, so just double check. Where's the curve? So point A is here, and we know it's 3 minus 3 over 2. We just plug this value in. So replace ax with 3, y minus 3 over 2. And this part takes a while. You just have to solve this step by step, okay? I don't think I'm going to explain it in detail, but just times this head on, so it'll be 6 over 5. And then make these both over 10. So times up and down by 5 and up and down by 2 to get these results. Make C the subject, and you should get minus 27 over 10. So this is the y-intercept, and therefore we got it. So here is our equation of normal, and we proved it. But they want it in a particular form, which is 10y equals 4x minus 27. So to get there, once you get this equation here, just have a look at it carefully and realize you should just multiply by 10, because they want 10y. So 2/5 times 10 will give us a 4, because 20 over 5 is 4. And then this 10 cancels out to get 27. And that's it, guys. That's literally A done. Now let's look at part B, because this is the main part I was talking about earlier. It says that the normal to C meets the curve again at point B. So the normal to the curve at A meets point B again. So this means that the straight line intersects again with the curve. And as you remember, when two things intersect, we're talking about simultaneous equations. Okay, so we're going to intersect this curve here with this line here. Okay, so that's literally the objective, and we need to solve and find the values of x and y, both pairs. Okay, so that doesn't sound too bad. So what I did, I just substitute, since we know that y, since we got an expression for y already from the curve, I just substitute all of this into the 10y equation. So we have 10 times the curve equation equals 4x minus 27 from the line. And then just expand and simplify. So 10 times all of this, you get 5x plus 270 over x minus 120. Throw everything to the left side, so subtract 4x and plus 27, you should get x and minus 93. And then just multiply and realize that, you know, this is the part where it gets confusion. When you have an equation like this and you're not sure what to do, try multiplying things. What I did, I just multiplied everything by x, because I mean, I'm familiar with this, but you should realize that when you times everything by x, you can get an x squared here, a constant here, and then another x term. So it looks a bit like this. So you get x squared here minus 93x and plus 270, and that's it, quadratic. Now to factorize this quadratic, and this one looks like I just knew it. We already know one of the solutions, because remember, we already know that it cuts through, the curve cuts through a and b, and we have the coordinates of a. One of them, it cuts at 3, x is 3, so we have a solution, and b is what we're trying to find. Because we know one of them is 3, so I plugged in 3 here, and we just need to realize that 3 times something will give us 270, and that has to be 90. 3 times 90 is 270, and actually coincidentally, well, not coincidentally, they're done on purpose, minus 3 minus 90 also give us minus 93, and that's it, you've done it. If you've done this, then literally, guys, give yourself a pat on the back, because you guys killed it. And at this point, now you got your x coordinates, so you know that this first one is x coordinate of a. For this coordinate for b, that's what we want, right? We want to find the coordinates of b. So with x equals 90, just plug into any of the two equations we started off with. I'm going to choose the line equation, because this one is actually, this will be fine too, but I chose the line equation because I think it's easier to work with. So when you do that, I mean, if you guys watch this, you guys pretty much did it. Plug in x equals 90 here. All of this will sum up to 333. Divide by 10, and that's it. You're done. You got your y pair, and that's it, guys. That's literally the end of the paper. So I just want to say thank you guys for spending your time watching this video, and I hope this benefits you guys. And yeah, good luck with your revision, and I'm gonna put the rest of them up. So I'll be putting every single paper online. Okay, if you guys got any questions or anything, let me know. If you guys enjoyed the video, please give me a like, share with your friends, subscribe. Just pass the word out. And yeah, and guys, make sure you have a really nice day. So, and I'll catch you all down the road. Ciao.